Hi everyone. So today we'll discuss about the searching in an array. How to search in an array. That is the main topic we will try to cover today. So what are the searching algorithms available? There are two searching algorithms available. One is the linear search, one is the binary search. Now first we will discuss about the linear search. What is the linear search? Linear search is nothing but just traverse the array and compare every element with the search key. So once you got that, hey, your array element is same as the key, stop traversing the array. That means you got the answer. Now, this is the simplest approach. What will be the time complexity of this approach? Time complexity of this approach will be O of n. When it will be O of n, in the worst case, when you will traverse the array up to the last, there can be two possibilities. If you are searching the last element of the array, or if you are searching the key which is not present in the array, then also you need to traverse the full array, isn't it? That's why time complexity will be of n. This is all about the linear search. Now I will just show you the code which I have written. So code will be very simple. You just need to take one array, the key which you want to search, traverse the array from 0th index to the last index of the array. If they are same, print and break out of the array. This is found variable I just used for the case when key is not present in the array. So let me just run it. You can see 100 is not present in the array. You will get the output as key is not present in the given array. Now if you will change it to 20, let's say, you will get the first index, 0th index, right? This is all about the linear search. I hope everything is clear in linear search. Now we'll move to the binary search. So what is binary search? Binary search approach actually follows the divide and conquer algorithm, in which we will divide the array in two halves and we will choose out of two halves, we will just go for the one. So once we are dividing our main array into some part and we will doing the same logic on that smaller part. That is the divide conquer algorithm. Now, very important thing, what is the prerequisites for the binary search? Your array should be sorted. For unsorted array, you can apply the logic, but this algorithm will not work and you will not get the correct output. What are the examples? Examples, let's say you have array. You can see the array. We have n at 7, key at 30. Now step 1 is get the middle element of the array. You need to get the middle element. Once you got the middle element, you need to compare the middle element with the key which you want to search. Now there can be three possibilities. Your middle element is same as the key. Just return the middle. No need to do anything now. Your turn. When array of mid is greater than the key, what it means? Your middle element is greater than the key. It means the key is present in the left side. Why? Because your array is sorted. So all the elements after the mid are definitely greater than the key. So no need to go in that direction. So we'll just call for the left array. Whenever key is greater, just call for the right side array. Right? So let's do the dry run once. So let's say we have this particular array. Okay, we have 10, 20, 30, 40, 50, 60, 70. Start is 0 and is the last index of the array, which is 6. So we'll just calculate the middle. Start plus end divide by 2. Your middle will be 3. Just compare the array of 3, which is 40, with the key. Key is 30 in this case, you can see. So 30 is less than the key. So key is less than the array of middle element. I need to go towards left side. So my new array will be 10, 20 and 30. So we have reduced the array by half. Now start is 0 and is 2. Just calculate middle, which is 0 plus 2 divided by 2, which is 1. So just compare the array of 1 with the 30. It is smaller than the 30, so we'll go for the right side. Now start and end both are same, mid is also same, so we got the answer. This is the simplest approach I can say. And the best part about this is we just did the 3 comparison 1, 2 and the 3, and in 3 comparison we got the answer. So let me just show you the code which I have written. The code for the binary search is simplest code. So you just need to pass call the one method which will take 3 parameters, start, end and the key. Now start is 0, end will be the length minus 1, which is 6. So first of all, this is the base case which is very important. Your start should be less than equals to end. If you will not apply this condition, you will get array index out of bound exception kind of thing you will get, and your recursive method will never end. So whenever you are writing recursive, just apply the base condition, means when you want to stop your execution part. So here middle is the element, just compare the middle with the key. If they are same, just return the middle element. If they are not same, there can be 2 possibilities. Mid is greater than the key, just go for the left array, or else go for the right array. Now since 70 is present in the array, let me just do the run once. Okay, we'll run it. We'll see hey, index 6 means 70 is present at the index 6. Whenever you will see hey, this key is not present, you will get the -1, which you can see line number 34 I have written. So this is the simplest approach. Now the question which is coming to your mind is might be the how to calculate the time complexity of the binary search and what is the time complexity. So here you can see time complexity of the binary search. I have written the recurrence relation, and how to calculate also I have explained here. So first line you can see t of n is t of n by 2 plus c. What is this line? T of n denotes the time taken to search in an array of size n. So what we are doing? We are doing one comparison with the middle element. Then we are either going to the left side or right side. Means we are just dividing the array by 2. So t of n will be t of n by 2 plus c. C is the constant. You can say it 1. Why 1? Because we are comparing with the middle element, means we are doing one comparison. So we have just added one constant as c. Now this is the equation 1. Just replace the equation in the equation 1. Replace n with n by 2. You will get t of n by 2 equals to t of n by 2 to the power 2 plus c. Again replace n with n by 2. You will get this equation. Now you just replace equation 2 and equation 3 in the equation 1. You will get t of n equals to t of n divided by 2 to the power 3 plus 3 times c. Now let us make it generic. We can see 2 to the power 3 plus 3c. So let's say 2 to the power 4k plus kc for k number of steps. Now we know that hey, whenever array size is 1, answer will be just 1. Number of comparisons will be 1. So when n divided by 2 to the power k is 1, then k will be log n. Just replace this k in this equation. You will get t of n plus 2 t of 1, which is 1, plus k multiplied by c. K is log n and c. So time complexity of the binary search is nothing but log n. I think everything is clear, and if you have any questions regarding the search algorithm, how to calculate time, anything is not clear, please comment out. I will definitely try to explain you guys. Thank you so much, guys.